We all kind of walk around with this basic assumption that systems are built to solve a specific problem. You build a structure, it does its job, and once the problem is fixed, it goes away, right? But if you look closely at any mature system out there, you're going to see an immediate contradiction. They don't terminate when the problem is solved. They expand. Ultimately, a system isn't evolving to solve a problem. It's evolving to sustain itself.
We see this happen all the time. Highly successful interventions continuously transition from problem resolution to process management. You see, a system almost never stops at its initial boundary. Instead, it starts consuming resources just to expand its own mandate. And the consequence here is deeply counterintuitive. As the system widens its reach, it eventually becomes structurally incapable of addressing the exact issue it was built to solve in the first place. To understand why this happens, we have to look at how structure dictates behavior.
Picture a single pipe. Its only function is to transfer a specific volume of fluid from point A to point B. It's efficient, it's closed off, and it's perfectly aligned with its single purpose. Nothing more, nothing less. Just fluid moving through a pipe.
But out in the real world, initial success in any organization or intervention spawns what's essentially a ratchet effect. When a system proves it can handle its initial capacity, the entirely rational local response is to demand more from it. So more ambitious interventions are introduced. And because a structure can't just easily throw away the capacity it's already built, it literally cannot reduce its scope. It only ratchets in one single direction: larger.
We can see this really clearly if we look at global financial architecture. When the International Monetary Fund was established back in the 1940s, its singular, specific framework was to maintain fixed exchange rates for developed countries. But by the 1970s, the gold standard was abandoned. So that initial problem effectively vanished. Did the system dissolve? No. Instead, it found new capacity. It shifted its focus entirely to funding developing countries. The structure survived by simply adopting a totally new problem. Back to our pipe. As internal pressure increases to handle a new volume of fluid, a pressure valve is added to the network to prevent a rupture. In human organizations, these kinds of valves enter the picture as simple, completely logical adjustments. People on a project team might suggest new technologies or maybe a few additional features to improve the intervention and handle the increased load. And you know what? Each of those suggestions makes perfect sense in isolation. But together, they start introducing this unexpected structural complexity that fundamentally alters the project's parameters. Think about the structural evolution of fusion centers in the United States. Created right in the wake of 2001, their initial highly specific focus was counterterrorism and infrastructure security. But the infrastructure was built, the data streams were connected, and the capacity was sitting right there. So, entirely rationally, the network expanded its parameters. It started sharing information on non-terrorist, general crimes. And this expansion escalates fast. By 2011, there were 72 of these fusion centers operating across the country. They were no longer constrained by those original parameters at all. The structure had successfully widened its mandate to ensure its continued operation, pulling in vast amounts of data that went way, way beyond its initial security mandate. Now, back at the pipe network, that new pressure valve regulates pressure, sure, but occasionally it restricts the flow entirely. Structurally, this mandates the addition of a bypass line, just so the fluid can keep moving when the valve is engaged. So now, a completely new component is added, not to solve the original problem, but strictly to manage the consequences of the previous addition. And as growing systems adopt these organizational bypasses and valves, they have to formalize rules to manage their new, highly complex functions. The organization is forced to adopt rigid bureaucratic structures and really tight procedures. It literally needs rules to govern the new rules. The system is no longer just processing the problem, it's processing its own complexity. To actually manage all of this, organizations often adopt what's called a matrix structure. Employees are grouped by function and then simultaneously grouped by product. What this structural adaptation does is multiply the layers of management. It creates an environment where internal coordination and power struggles over shared resources become the actual daily reality, rather than, the original output. The network is tangling. That bypass line now necessitates a diagnostic sensor just to monitor the fluid flow. Each rational addition makes the physical structure significantly heavier and infinitely more fragile. As the scope of all this enlarges, the system inevitably slows down. The new requirements demand constant internal communication. Additional meetings are scheduled for no other reason than to coordinate the new additions and resolve those matrix conflicts we talked about. The organization's energy is now directed almost entirely inward, just managing its own weight.
The resulting fragility here is profound. The system begins to manage the managers of the product. The organization no longer primarily produces the solution. Instead, it simply manages the complex layers it created to govern the solution. The actual output becomes totally secondary to the administration of the output.
This relentless structural force, this continuous addition of features that fundamentally alters the project, is often called scope creep. But it's really important to understand that this isn't a failure of individual intent. Nobody planned to ruin things. It is an uncontrollable structural growth beyond initial parameters, driven entirely by the system's inherent design to accommodate new, localized demands.
This expansion violently pushes the system's time frame and its costs outward. And the escalation continues until a breaking point is reached. The system either collapses entirely under its own structural weight, or higher-ups start seeking entirely new alternatives simply because the current system has become way too heavy and expensive to move.
As the organization fights to just survive all this weight, establishing structures for internal concerns takes precedence over the actual original mission. Resolving employee disputes, maintaining that matrix hierarchy, and feeding the bureaucracy, these become the system's primary operations. The original focus is effectively buried beneath the desperate need to simply keep the organization intact. Eventually, repeating successful internal behaviors consumes the organization entirely. Let's say a company starts a simple annual charity drive, maybe just for good publicity. If it's successful, it becomes a tradition. And that tradition demands more resources, more committees, and more time until these internal traditions drain the exact energy required for the actual mission.
So, when an initial problem is resolved, the system doesn't just shut down. It executes a mechanism known as goal displacement. The original goals are entirely replaced by new internal concerns, purely to justify continued existence. The system creates brand new objectives that exceed its original mechanisms, simply so it can survive.
We can observe this clearly in the March of Dimes. They were founded in 1938 with one highly specific goal: the eradication of polio. But when the polio vaccine effectively defeated the disease in the 1950s, the organization didn't disband. Instead, it entirely displaced its goal to combating birth defects. The structure sustained its existence by swapping out its foundational purpose.
Look back at the pipe. It is no longer a single pipe. It's a hyper-complex, frozen tangle of valves, bypasses, sensors, and secondary bypasses. It is a locked knot of perfectly rational additions. And because of this immense, conflicting complexity, absolutely no fluid volume flows through the network anymore. The physical system is completely paralyzed. The very mechanisms that were added over time to ensure and protect the flow have irreversibly stopped it. The system didn't fail because it was broken. Every single addition was a rational local optimization. It expanded, it paralyzed itself, and it displeased its purpose because it perfectly followed its structure. The system was never failing. It was exactly following its design. So look at the systems, the bureaucracies, and the structures governing your own life. Are they actually still solving the problem they were built for, or are they just managing the complexity they created?